So good morning, welcome to SAKALAVIDYA YouTube channel. Good morning to the Eamcet 2020 classes. So today the functions. So in the last class we have discussed up to uh, integer function, step function. Now we discuss today fractional part function. Okay, right. Fractional part function. Fractional part function. Okay. The function f maps R to R is defined as f of x equals to x minus integral part of x. That means x contains integral part and fractional part. If you subtract integral part from any number, you will be getting fractional part. Or this can be written f of x is equal to fractional part of x. This is a symbol for the fractional part of x, where this is called, bracket is called fractional part of x. Fractional part of x is called fractional part function. Fractional part function. So domain of this function is R, set of real numbers. Range means it lies in between 0 to 1. So closed 0 comma 1 open. Okay, so let us discuss the properties here itself only. The properties of this one now. See, first property, integral part of x equal to x. That implies fractional part of x equals to 0. Here x belongs to integer. Second one, integral part of fractional part of x, obviously 0. Next, 0 less than or equal to fractional part of x less than 1. See, range is 0 comma 1. So one more important point, this better remember this one, this will be useful for the problems. Fractional part of x plus fractional part of minus x equal to 0 if x is an integer, equal to 1 if x is not a integer. So this is about the fractional part. Okay, next, Signum function. This is called signature function also. Signum function. signum function. Okay, the function f maps R to R, f maps R to R, defined as f of x equals to mod x by x for x does not equal to 0. 0 for x is equal to 0. This type of function is called signum function. So why should we call signum function? Means the mod x may be plus or minus x. Plus or minus x will be 1. That means function is 1 minus 1 0. Understood now? So that means signum function means a sign function. Sign, either plus sign or minus sign, you will get it now. Okay. So this is called signum function. Okay, you can go. Don't come once again now. Signum function. Domain. Here domain of this function is equal to set of real numbers. Range equals to -1, 0, 1. Wait 1 minute. Right. We don't want such viewers. Right. Operations on functions. Operations on functions. Operations on functions. Right. Operations on functions. Let f and g be two real functions with domain that means having domain d1 and d2 respectively. That means d1 is the domain of the function f, d2 is the domain of function g. Okay, though Eamcet may be postponed, but it will be conducted because it's a deciding factor to get into the admission into the engineering. Let f and g be two real functions with domain d1 and d2 respectively. So next, first one, the sum function. The sum function means, can the two functions be added? We get new function. If you add the two function, we'll get another function. That function is called sum function. Sum function f plus g. For example, add f and g. F plus g is defined by f plus g of x equal to, we can write f of x plus g of x. Two functions are added. Here, for every x belongs to d1 intersection d2. It's very important. So if you know the domains of the functions f and g, and if you are asked to find out domain of the function f plus g, so domain of the function f plus g is the intersection of the domains of f and g. That means we need to find out. Thank you. Next, now second one, even difference function also we can define. The difference function of f and g, that is f minus g, even you can define g minus f also, no problem, is defined by f minus g of x equal to f of x minus g of x. Here, for every x belongs to d1 intersection d2. This is very important factor. Okay. Right. Second, let us discuss. Third one is the product function. The product functions. That means two functions can be multiplied. The product function. The product function fg is defined by fg fg of x equal to f of x times g of x, f of x multiplied by g of x. Here also the domain of this function is x belongs to d1 intersection d2. d1 intersection d2. Suma, today Suma is not there. Rameshwar Reddy. Kumshi Krishna Yadav, just block them. Okay. Right, next. Fourth one. The quotient function. The quotient function f upon g. This is quotient function. So you block them. Anybody if short, Pramila, yourself also. If anybody actually chart other than academic issues, subject, just block them. We need not require such persons. Is defined by f upon g of x equal to f of x upon g of x. For every x belongs to d1 intersection d2, but here x such that g of x equal to 0. That means g of x does not equal to 0. Okay, definitely Kirti, I will start it. Suma, you just black Parvati, Miss. Right. Next, fifth one is scalar multiple function. The scalar multiple function. Scalar multiple function. CF. C is the constant multiplied by F. Is defined by C f of x equal to C times f of x. That means we can multiply any function with the constant also. Here for every x belongs to d1. Okay, next, composition of the functions. Composition of the functions. Composition of function. Okay, composition of function. Right. So for example, let f maps A to B, G maps B to C be two functions. Then a function defined from A to C is denoted by G circle F and defined as G circle f of x equal to G of f of x for every x belongs to A is called the composite function of f and g. Leave it, Hariprasad Reddy, please don't ask again. I got it. I will keep in mind. Okay, that means actually see, this is A, B, C. A, B, C. Now the function is defined from, this is f function A to B, this is G function. Suppose from here to here, this is called G circle F function, composite function from here to here. Suppose if you say this is x, this will be y, this will be z. See here clear, so we can write like this. So Z equals to G of y equals to f of x, that is G f of x. This is nothing but G circle f of x. G circle f of x. Right. So now one more thing, remember in this one important point. What is the domain of G circle f? Domain of G circle f is A. Next, the range of G circle f is C. That means the domain of G circle f is equal to domain of f. Range of G circle f is equal to range of G. You must remember that one. Right. So now you can write like this here. Important point. Domain of G circle f equal to domain of f. Domain of f. Range of G circle f equal to range of G, function G. Even in the similar manner, you can define f circle G of x also. That's equal to f of G of x. Okay, now let us go for move to the some model problems. After that, again I discuss. Actually, in functions we have so many concepts, so we need to discuss. But I discuss after the some problems. Let us do some problems today. After that, tomorrow we shall discuss the concept followed by the functions. Okay. So now let us move to the problems now today. One minute. So till then, just go through the concepts what we have discussed till now. Okay. Right. Problem number 1. Let this is problems now. Problems. Let A be a set of n distinct elements then the total number of distinct functions from A to A is first option n square, second option n to the power of n, n raised to n. Third option 2n. Fourth option n factorial. Fourth option n factorial. Now, let A be a set of n distinct elements, then the total number of distinct functions from A to A defined. That we need to find out. So that means actually here see solution. Here n of A equals to number of cardinality of set A is n is distinct. Therefore number of functions defined from A to A equals to n of A to the power of n of A. So that equal to n raised to n. That means second option is the right option. Second option is the right option, not fourth option. Fourth option is that is number of injections. Right. Option 2 is the right option. Question number 2. Pawan Sai, I will clarify the doubts later. You ask me after that. Okay. Set A has 3 elements. Set A has 3 elements and set B has 4 elements. The number of injections that can be defined from A to B is, this is the question. Set A has 3 elements and set B has 4 elements. The number of injections means one-to-one functions, that can be defined from A to B, that we need to find out. So first option is 144, second option is 12, third option 24, fourth option 64. Fourth option is 64. So first we need to write the cardinality of the set A. Next we need to write the cardinality of B, that is n of A and n of B. N of A is 3, n of B is 4. We need to check whether n of A is less than n of B. If n of A less than n of B, then only one-to-one function or injection may be defined, or else number of injections will be 0 if it is not possible. That we need to check it first. Solution. Let us move to the solution. N of A equals to 3, n of B equals to 4. So that implies we have n of A is less than n of B. Now one-to-one functions can be defined now. Therefore number of injections from A to B equals to, what is the formula? N of B, P means permutations, N of A. So this equals to, we can write 4P3. 4P3 equals to what we can write now? 4 factorial by 4 minus 3 factorial. You know NPR formula. What is NPR? N factorial by N minus R factorial. Right? So this is equal to 4 factorial means 4 into 3 into 2 into 1. 24 upon 1 factorial. 24. So third option is the right option. Third option is the right option. Not so 4P3. 4P3. 4 N. See what is the formula actually we have here? You remember NPR equals to N factorial upon N minus R factorial. Am I correct? This is the formula. Okay. So with the help of this I solved. Suma got it. Preeti, yes, very good. Sudha, Pavan Sai. Okay sir, why okay sir? Right. Muhammad Sahil Ali, what happened to him? I don't know. Right. Third problem. Problem number 3. Right. Problem number 3. Let N of A, sorry, wait. The number of 1 to 1 functions, 1 to 1 functions that can be defined from 1, 2, 3, 4, 5. That means elements of the sets are being given here. To A comma B comma C. A comma B comma C is first option 120, second option 24, third option 20, fourth option 0. Right. So now we need to find out the number of 1 to 1 functions that can be defined from 1 comma 2 comma 3 comma 4 comma 5 to A comma B comma C. That means, suppose let us say A equals to 1 comma 2 comma 3 comma 4 comma 5. So that implies now you can write N of A. Number of elements present in A, distinct elements, that is 5. Let us say B equals to A comma B comma C. Cardinality of B is N of B is equal to 3. Now you check it now. From this one here, N of A is greater than N of B. Now we need to think, can we define 1 to 1 functions from A to B? No. in order to define one-to-one functions from A to B, it need to be n of A less than or equal to n of B. Since n of A greater than n of B, no one-to-one function can be defined. That's why the number of one-to-one functions or injections is 0, absolutely. That means, therefore, number of one-to-one functions from A to B equal to 0 since this condition. Fourth option is the right option. Fourth option is the right option. Right. So 0, absolutely correct. Fourth point. The fourth point already we have discussed. The fourth question now we need to check. Let n of A equals to 4 and n of B equals to k. N of B equals to k. Everybody is correct. Wonderful job. The number of all possible injections means one-to-one functions only, don't get any confusion. Injections from A to B, is 120. Then k equals to first option 9, second option 24, third option is 5, fourth option is 6. Okay. See, in this question, the cardinality of A, n of A is equal to 4. The cardinality of B, n of B is equal to k. We do not know k value. The number of all possible injections from A to B defined as 120 given. Then we need to find out the k value. This is the question. First, we need to write already the number of injections are given. That means the injections will be possible from A to B. That's why actually here n of A is less than n of B. So that we can write now the number of all possible injections from A to B is equal to n of B p n of A. That is equal to 120. So then we need to find out the k value. So let us see. Solution. Number of injections from A to B is given 120. That means NB P NA. But one thing, this NB greater than or equal to N of A equal to 120. That means K P4 equal to 120. Kp4 is equal to 120. So Kp4 is equal to 120 means the Kp4 is equal to, we can write like this now. K times K minus 1 into K minus 2 and K minus 3. Okay. Equals to 120 we can write. This 120 we can write 5 into 4 into 3 into 2 into 1 we can write it. 2, up to 2 we can write, no problem. So now even equating this k equals to 5 or k minus 1 is equal to 4. Therefore k equals to 5. So this is the answer. Because you see this 5p4, you can check it now. 5p4 is equal to 5 factorial by 5 minus 4 factorial. 5 factorial is 120 upon by 1, 120. That's why the k must be equal to 5. You can check like this also. Right? Okay. Shall we move to the next question? Right. Let us move to the next question. Fifth one. Let n of a equals to 4, n of b equals to 5. The number of all possible many to 1, because 1 to 1 functions are not defined. Many to 1. If the functions are not 1 to 1, they said to be many to 1. All possible many to 1 functions. From A to B is first option is 625, second option is 20, third option is 120, fourth option is 505. This is the question. Surya, Vaibhav, Monica, Varun, you are new to the class, so have you subscribed or not? N of A, cardinality of A is 4, the cardinality of B is 5. The number of possible many to 1 functions from A to B we need to define. So in order to find out many to 1 functions, first we need to find out total number of functions that can be defined from A to B. So after evaluating total number of functions from A to B, then we need to find out next number of 1 to 1 functions we need to write it. That's okay. Right. So first write down total number of functions. Sorry, in this case 1 to 1 functions are defined. Okay. Not y or not y. Sorry. Some others. Okay. Total number of functions. The total number of functions means we can write n of n of b raised to n of a. So that is equal to 5 to the power of 4. 5 to the power of 4 is equal to 625. Next, now number of 1 to 1 functions. Number of 1 to 1 functions can be defined, okay, because n of a is less than n of b. equal to n of b p n of a. So that is 5p4. Just now in the previous case we have done 5 factorial by 5 minus 4 factorial, 1 factorial, which is 120. Okay, therefore number of many to one functions, number of many to one functions equals to n of b raised to n of a minus n of b p n of a. So whose value equal to 625 minus 120. We need to subtract 120 from 625 so that we get exactly correct. You are 505. Yes, absolutely correct you are. Preeti, Trinad, Sudha, Vaidipalli, Rachamalla Mahesh, wrong. You check it now. Not 5 factorial. Kotur Pushpa. Have you subscribed? First you need to subscribe. Next, let us move to the sixth question. Right. Sixth one. Set A contains three elements. Set A contains three elements and set B contains two elements. The number of onto functions from A to B is, this is the question. Right. First option 3, second option 6, third option is 8, fourth option is 9. No. Right. Set A contains three elements. N of A is equal to 3. Set B contains two elements. N of B is equal to 2. Then we need to find out the number of onto functions from A to B. Okay. Let us say like this. M equals to N of A, whose value is M. N equals to N of B, whose value is 2. Now number of onto functions, right? Formula: number of onto functions. Number of onto functions is equal to, here, n to the power of m minus nc1 n minus 1 to the power of m plus nc2 n minus 1 n minus 2 whole to the power of m minus dash dash dash. Right. Let us substitute the value. Here n means 2, this will be 2 cube minus 2c1, 2 minus 1 is 1, 1 to the power of m. Because 2 minus 2 is 0, you need not write these terms. Up to this is enough. So m means how much actually here? 3. This equal to 2 cube is 8, 2c1 is 2 multiplied by 1. 8 minus 2, whose value is 6. That means second option is the right option. Second option is the right option. Not option 3, Arjun, you check it now. Next, 7th question. 7th one. 7th one. Let A equals to 1, 2, 3, so on dash dash n. That means set of natural numbers. Right. A is equal to 1, 2, 3 and dash dash n, and B equals to A comma B comma C. A comma B comma C. Then the number of functions from A to B that are onto, that means number of onto functions that are onto is first option 3 to the power of n minus 2 to the power of n, second option 3 to the power of n minus 2 to the power of n minus 1, third option 3 times 2 to the power of n minus 1, and fourth option 3 to the power of n minus 3 times 2 to the power of n minus 1. This is the question. Right. A equals to 1 comma 2 comma 3 comma so on n. That means number of elements present in A is n. The number of elements present in B is 3. So that means, say m is equal to n and n is equal to 3. Then we need to apply the formula. Okay, let us do it now. This is A, set A, this is set B. Number of onto functions from A to B we need to find out. See the solution. M equals to n of A, that is n. N equals to number of elements in B, that is 3. Now number of onto functions. From A to B. What is the formula? N to the power of m minus nc1 n minus 1 raised to m, okay, plus nc2 n minus 2 whole to the power of m minus dash dash, because after that you will be getting n minus 3. Leave it now. So this equals to 3 raised to n minus 3c1. 3 minus 1 is 2. M is equal to n. 2 power n plus 3c2. 3 minus 2 is 1. 1 to the power of n. So this equals to, we can write 3 raised to n. 3c1 is 3 times 2 power n. 3c2 is 1 and 1. This can be written 3 raised to n minus 3 common. We get 2 raised to n minus 1. That means fourth option is the right option. Fourth option is the right option. Suma, you check it once again. Praveen Kumar, Vaibhav, you check it. Yes, Suma, you are correct. Narendra, you are correct. Prasann Hani. Right. Sudha also. Vaibhav. Eighth, set A has three elements. Comma, set B has 4 elements. The number of surjections that can be defined from A to B is, surjections means onto functions, don't get any confusion. Okay, first option is 144, second option is 12, third option is 0, fourth option is 64. Yes, Monica, you are new. Vinod Kumar, Bukhya, you are also. See, set A has 3 elements. N of A is equal to 3. Set B has 4 elements. N of B is equal to 4. Then number of surjections from A to B we need to find out. Understood now? So let us proceed. Solution. Say M is equal to N of A, whose value is 3. Say N equals to N of B, which has 4 elements. Okay, this is say. Number of surjections. Surjection is nothing but onto only. Don't get any confusion. Number of surjections from A to B equals to n to the power of m minus nc1 n minus 1 to the power of m plus nc2. Okay, n minus 2 all to the power of m minus nc3 n minus 3 all to the power of m plus dash dash. Let us substitute the respective values of m and n. Who is Mr. Ramareddy? Now let us substitute. N is 4. 4 to the power of 3, 4 cube minus 4c1. 4 minus 1 is 3. 3 to the power of 3. 4c2 is 4 minus 2 is 2. 2 cube minus 4c3. 4 minus 3 is 1. 1 to the power of 3. Just simplify these values, then you will get the answer. So Padma Madhyapeta, any book is actually useful for the Eamcet. I will collect the problems from the useful books. Okay. Just try to understand the problem. The book doesn't matter. Concept is very important. 4 cube. 4 cube is 64. 4c1 is 4. 27. 3 cube. 4c2 is 6. 2 cube is 8. 4c3 is 4c1. 4 into 1. This we need to simplify. 64 minus 108 plus 48. So minus 4. Minus 4. So that means how much you will be getting? Right. This is 108 minus 108. 108 minus 108 minus 4. So no negative terms. That means 0. This we can write 0. That's why third option. Third option. So otherwise you can do directly also. It's clear that n of b is greater than n of a. So therefore number of onto is 0. Directly also we can write. Ninth question. Let A comma B are two sets each with 10 elements. Then the number of all possible bijections from A to B is. Bijections means the function which is one-to-one and onto both. Thank you, congratulations. Okay, let A comma B are two sets each with 10 elements, then the number of all possible bijections from A to B. Okay, so once again I congratulate all who got success. So marvelous results, wonderful results in your IPE. That's enough. Thank you. So first option is 20, second option is 10 factorial, third is 100, fourth is 1000. Okay, welcome. Definitely, I bless all the your children to get more credentials in your future. Solution. Here n of A equals to n of B equals to, they have the equal number of elements. So that's why actually here. So now here number of bijections. Now bijections can be defined. The bijections can be defined if and only if n of A is equal to n of B. That you remember one thing. Now the number of bijections. Number of bijections from A to B equals to n of A factorial or n of B factorial. Both are same. So that equal to 10 factorial. So second option is the right option. Second option is the right option. Tenth one. Right. I don't have the idea, Abhinav Reddy. The number of one-to-one onto, that means bijective, one-to-one and onto functions that can be defined from 1, 2, 3, 4, the set 1, 2, 3, 4 to set B is 24, number given. Then n of B equals to, first option 4, second option 2, third option 3, fourth option 6. Right. The number of one-to-one onto functions that can be defined from A to B. That can be defined from A to B means here n of A equals to n of B. That's all. So that we can find out n of B here. So therefore here solution is what? Since bijections are defined from A to B, therefore n of A equals to n of B. Already n of A, how many elements are there? 4 elements. That implies n of B equals to 4. That's why first option is the right option. Our desired option is 1. Next, 11th question. 11th question. If A comma B are two sets such that n of a equals to 100, n of a equals to 100, n of a is equal to 100, and n of b equals to 150. Then the number of bijections, the number of bijections from A to B is first option 100 factorial, second 150 factorial, third 150 p 100, fourth 0. Abhishek Jakula, now you are getting answer. See in this one. See, A comma B are two sets such that n of A equal to 100, n of B is equal to 150. That means n of A does not equal to n of B. So the bijections cannot be defined. So the number of bijections is equal to 0. So that's your answer, Abhishek Jakula. Okay. Solution: n of A 100, n of B is equal to 150. Here it's clear that, or we know that, n of A does not equal to n of B. Therefore, number of bijections is 0. So fourth option is the right option. Fourth option is the right option. Today 4:30 actually I plan to take for outgoing students, okay, keeping you of your examination and requisitions from the viewers. 4:30 also will be kept for allotted to Eamcet students only. In 4:30 I will continue binomial theorem. Okay, so after night session, that will now the session is not meant for you, so that will be for only absolutely for intermediate students. Okay. Right, we will try. Okay, we will try. Twelfth question. A equals to 1, 2, 3, 4. 1, 2, 3, 4. B equals to, so inform to your friends also. Night timings means it might be 7:30. Don't worry, Pramila. So you make a call to me. Rasannahani or Suma, give to Pramila. I will discuss with Pramila regarding JE. A comma, B comma, C comma, D comma, E. Right. A is equal to 1, 2, 3, 4. B is equal to A comma, B comma, C comma, D comma, E. Then so note down, Pramila, my number. So you make a call after my class. then the number of all possible constant functions from A to B. See, all type of models have been covered in this one now. Now you are able to do any problem on number of different kinds of functions. From A to B is first option 9, second option 4, third option is 5, fourth option is 16. Okay, Pramila. Right. You may call me, no problem. So I will discuss regarding to the JEE Mains so that we can make a plan. A equals to 1, 2, 3, 4. B equals to A, B, C, D, E. Then number of all possible constant functions from A to B. So we need to write. Okay, wonderful. Okay. So now the solution. N of A is 4. N of B is 5. So we have the formula number of constant functions from A to B equal to number of elements present in B. That is 5. So answer is 5. That's all answer. B to A means 4. Option 3, absolutely correct. Okay, now 13th one. If f of x equals to alpha x plus beta, whatever problems we have discussed earlier, isn't it now? The based on number of functions, main class timings will be, I will decide. Please make a call to me, VSK. If I need to discuss with you and I will confirm the timetable. Right. If f of x is equal to alpha x plus beta and f equals to 1, 1, this is set builder form, 2, 3, 3, 5 and 4, 7. Then the values of alpha, beta are I already given morning 9:30 to 11:20 or 11:15 is morning classes and evening 4:30 to 5:30 is Eamcet, and evening I will decide with discussing with the others. Okay, first option is 2, -1, second one is -2, 1, third one is 3, -1, fourth option is -2, -1. Okay, it will be continued. Every chapter I will cover. Don't worry. See, f of x is equal to alpha x plus beta. F is equal to 1 comma 1, 2 comma 3, 3 comma 5 and 4 comma 7. Okay. So now, as for the definition of this function, f of 1 means 1. This is just like x comma y. Y is equal to f of x. That means image of 1 under f is 1. So that means f of 1 is equal to 1. F of 2 is equal to 3. N of these values. Substitute in this one. F of 1 means alpha plus beta equals to 1. You get one equation. F of 2 means you get 2 alpha plus beta is equal to 3. Say equation 2. These two are the linear equations in two variables. Solving 1 and 2. Solving 1 and 2. Okay, I asked you, Arshid Reddy, one question. Can I stop all these topics in the middle? Tell me. So if I stop all these topics, then I will start conics. So one by one I will complete it. So you need to wait, because you are going to write the examination, but I am not going to write any examination, isn't it now? Please try to concentrate on this one. So okay, 2 alpha plus beta equals to 3. Alpha plus beta equals to 1. Subtract alpha plus beta is equal to 1 from first equation. Minus, minus and minus. Beta gets cancelled. We have alpha equals to 2. Now from 1, substituting alpha is equal to 2 in equation 1. You get 2 plus beta equals to 1. So beta equals to 1 minus 2, whose value is minus 1. That means alpha comma beta equals to, what do you write now? That is 2 comma minus 1. So that's why first option is the right option. 2 comma minus 1 is the first option. Am I correct now? Fourteenth problem. So now we have been discussing level 1 problems, but in functions we have up to level 3 problems also. So you need to remember. So how is the sound voice now? Voice is okay, everybody? Because I changed the new system from other system to the new sound system. I think it is very comfortable to you and audible to you. Am I correct now? So one of the viewers actually suggested me to get this type of device. I purchased a new device for sake of you people, so that it should be audible to you. Thank you. If f of x, definitely I will take your suggestions also. As for your suggestions, we will update ourselves. That's why I asked, that is, I couldn't name that, Tippavajira, to make a Pramila, to make a call to me, so that we shall make a plan ourselves. Thank you. F of x equals to 4x minus 1 if x greater than 4. It's called actually piecewise functions. X square minus 2 if minus 2 less than or equal to x less than or equal to 3. These kind of problems are very important for even board examinations also. 3x plus 4 if x less than minus 2, then f of minus 3 plus f of 5 plus f of 0 plus f of minus 1 upon f of minus 2 plus f of 1 plus f of minus 5 plus f of 3 equals to Mohan Rao. Actually, I am not good at the technical issues. Infinite Kings, you might have not actually visited my playlist. First go through the playlist and ask the question. First option 11 upon 3, second is 3 upon 11, third option minus 11 upon 3, fourth option minus 3 upon 11. Okay. Prithvi, I already given blueprint of Eamcet. You visit playlist. Solution. See, this is called given expression. Let us say this is given expression is equal to f of minus 3. Minus 3 means x comes under this interval because x less than minus 2. Minus 3 belongs to this interval x less than minus 2. So that means minus 3 into minus 3, 9, minus 9, minus 9 plus 4, minus 5, okay, 5. 5 means x greater than 4, 20 minus 1 plus 19, 0, 0 lies between in this interval. So 0 minus 2, that will be minus 2, and f of minus 1. F of minus 1 means actually lies in between this interval only. So 1 minus 2, minus 1 upon minus 2. Minus 2 is this interval, 4 minus 2, 2. 1 lies in this one only, minus 1. So now minus 5. Minus 5 means x in this interval, minus 11. 3. 3 lies in this interval, 9 minus 2, 7. We need to simplify this one. 19 minus 8 upon 19 minus 8 upon, actually you will be getting 9 minus 12. 11 upon minus 3. You can write minus 11 upon 3. Third option is the right option. I don't have the idea, Padma, because it's a being live session, live streaming, so some community guidelines I need to follow. So I don't disclose all these things. If you want, you can call to me, then I will discuss. Thank you. Fifteenth problem. Yes, Pramila. Srija. After a long time. Vaibhav. Sudha. Suma. Right. Let F maps R to R be defined by f of x equals to x plus 2, x less than minus 1, x square minus 1 less than x less than or equal to 1. Okay, 2 minus x, x greater than 1, then the value of f of minus 1.75, f of minus 1.75 plus f of 0.5 plus f of 1.5 is, first option is f of 0, second option f of 2, third option f of 1, fourth option is f of 3. So this is the question. Right. So now we need to check the minus 1.75 belong to the which interval. Similarly 0.5 and 1.5. In accordingly we need to find out f of minus 1.75 and f of 0.5 and f of 1.5, and again we need to check the options. So method need to be applied here. That only I am explaining. You might have not attended the yesterday class. Watch yesterday part 2, part 1, part 2 classes. That's absolutely concept class only. Right. So now let us move to the problem now. Solution. So f of minus 1.75 is x less than minus 1. Minus 1.75 plus 2. That means from 2 subtract 1.75. You will be getting 0.25. Now f of 0.5. F of 0.5 means it lies between minus 1 and 1. So that means 0.5 square. 0.5 square is 0.25. And f of 1.5. F of 1.5 means 1.5 is greater than 1. 2 minus 1.5. 2 minus 1.5 is equal to how much? That will be 0.5. So adding the given expression is equal to 0.25 plus 0.25 plus 0.5. 0.25 plus 0.25 is 0.5 plus 0.5. That is 1. So 1 means if you substitute actually here x is equal to 1 here, you try 1 square. You can write 1 square. 1 square means x square, that is nothing but f of 1. So that means third option is the right option. Third option is the right option. Okay, can I proceed for the 16th problem today? Okay, are you following, all of you? Yes, Suma, Infinite Kings, Karthik, Akki, K. Preeti, Prudvi, Rajesh. Okay, Pushpa, very good, Nana, all of you. Wonderful job you are doing. 16th problem. 16th. If f of x equals to 3x minus 2, x greater than or equal to 3, x square minus 2, minus 2 less than or equal to x, x less than or equal to 2, 2x plus 1, x less than minus 3. The function is defined. So in such a manner. Try later, you will get it now. But now I cannot do anything because I need to concentrate on the problem. So then f of 4 plus f of minus 4, f of 0 plus f of minus 7, f of 2 plus f of 25, or in first one is AGP, second one is AP, third one is harmonic progression, fourth one is geometric progression, GP. Right. So we need to find separately values f of 4 plus f of minus 4, and f of 0 plus f of minus 7, and f of 2 plus f of 25. We need to check the conditions for arithmetic geometric progression and arithmetic progression and harmonic progression and geometric progression. Right. Part 3. Yes, in playlist part 3 check. Right. He has given the clue also to you. So first let us say A equals to f of 4 plus f of minus 4. The 4 belongs to this first interval. So 4 3 are 12, 12 minus 2, 14. Minus 4 belong to this interval. Minus 4 into 2, minus 8, plus 1, minus 7. 14 minus 7 is 7. Similarly, next value, B value, f of 0 plus f of minus 7. So since 0 belongs to the second interval, 0 square minus 2, minus 2. Minus 7 belongs to the third interval, minus 14 plus 1, minus 13. This will be minus 15. See now. Say C f of 2 plus f of 25. 2, since 2 belongs to the second interval, 2 square, 4 minus 2, 2 plus 25. 25 means first interval, 25 3 jar 75, 2 plus 75 minus 2, 73. This will be 75. Okay. Right. So now you can check it. Minus 15 plus 7 is minus 22. 75 plus 15. No, it's not AP. It's not AP means obviously it is not in harmonic progression. These two options are eliminated. They are being eliminated. Now we need to check B equal to how much? Summa 3. I will check f of 4. F4 is 12. Exactly. I will check it now. Wait now. Okay, I will check it now. F of 4, 12 minus 4 3 are 12. 12 minus 2 is 10. Minus 4. Minus 4 means minus 8 minus 7. Absolutely correct. 3. Yes, wonderful. So now find the B square value now here. B square minus 15 square. Minus 15 square is equal to 225. Find AC. 3 times 75. 15 225. Therefore B square is equal to AC. Therefore A, B, C are in geometric progression. Thank you, Suma. Exactly correct. Okay. Now Mr. Kiran Kumar, you check it now. Now you can check it. Not think GP, GP only. Okay. Right. What about your other Siva? Dishwank is not there. Chintu. What about Madhurima? Okay. 17th question. Okay. Tomorrow I will discuss the 17th question. Okay. Till then, goodbye. Thank you. Bye bye. See you. Have a nice day. Stay safe. Stay home. Stay at home. Okay. Right.